So thank you for watching the communication system playlist. So in this lecture, we are going to discuss about the different type of pulses. And the main types are the NRZ, RZ, Manchester. So we will try to explain one by one. So very simply, the first type is the NRZ. So what does that mean? NRZ mean not return to zero. So what does that mean? So having a characteristic not returning to zero. So what does that mean? So if you draw the signal, this is the amplitude y-axis and x-axis is the time, and there is a tb, so which is known as bit duration from 0 to t. So the pulse duration is tb, and up to tb the amplitude of the pulse remains a, and other than that it is 0. So it means that up to the pulse duration tb amplitude will remain constant throughout the entire duration tb. So what does that mean? Pulse occupy entire bit duration with the fixed amplitude. As you can see, from 0 to bit tb is the bit duration, its amplitude remains constant. A. Second type is the RZ, which you can see return to 0. So again you can draw the pulse here. So this is the y-axis amplitude and this is the x-axis time. And here TB is the bit duration and TB by 2 is the half bit duration. So you can see that after half bit duration, pulse return to 0. Like here, the amplitude till the half bit duration remains constant A, and after the half bit duration, pulse return to 0. The amplitude is 0. So it means that for half of the bit duration, the amplitude will remains fixed and are constant, and for another half, the amplitude remains 0. Or you can say the pulse occupy half of the bit duration, that is TB by 2. The third important type is the Manchester pulse. So if you draw the signal for this as well, so you can see this is the positive level and then this is the negative level. And then you can see this is the bit duration TB and this one is the half bit duration, that is TB by 2. So for this you can say for half of the bit duration amplitude is positive A, and for another half of the bit duration amplitude is negative A, as you can see here that for the first half bit duration the amplitude is positive A, and for the next half duration the amplitude is negative A. So it shows a translation from positive A to negative A during half of the duration. Like from the amplitude is going to be changes in between positive A and negative A, and this change occurs at the half bit duration. At half bit duration, there is a transition. Like in another word, you can also define this that at half duration TB by 2, there is a transition from high to low level or from low to high level. So this was the uh, type of the pulses. Another is the pulse shaping technique, and the pulse shaping technique usually is of three types. First one is unipolar, the second one is polar, and the third one is bipolar. So one by one we are going to define these techniques. The first one is the unipolar. So it means that you are going to assign voltage level with respect to the bit. So as the technique is that you are going to convert the digital data into the digital pulse or into the digital signal. So that is why it means that for each data bit given you need to assign a voltage level accordingly. Like usually the data is always in term of 0 and 1. So for example, we are given two bits. The first is 0 and the second one is 1. And we need to assign level. the pulse level. So which the first one is 0 and the second one is positive A. Positive A means can be of any level of voltage. It can be plus 1, it can be plus 3, it can be plus 5 or 5.5 or 9 volt, whatever, because it is a DC. So it means that for 0 bit you are going to assign a 0 level, and for 1 bit you are going to assign a positive A voltage. So if this type of assignment is there, you can call this a unipolar technique. The second is the bipolar technique. What does the polar technique mean? So again, you are going to assign bits to a level. So if there is a bit 1, so then your assignment is positive A. But if the bit is 0, so your assignment is negative A. So it means that you are assigning two values like either positive voltage or negative voltage. If you see this type of assignment, you can call this technique a polar technique. The third technique is bipolar. So here you can see this is two level, two data bit and two level. So here again, and you can see the unipolar as well, two data level and two signal level, similar to data level, two signal level. But what about the bipolar? So for the bipolar, again you are going to assign the levels for the given bits. For example, you have bit 1 or 0, and then you need to assign the levels. So for bit 1, you need to assign either plus 1 or minus 1, and for 0, you need to assign 0. So if you see this, so you can see you are assigning three levels. So the level assignment is 3, but the bit data bit levels are only 2. So it means that, so this is also known as three different voltage levels. So you are assigning three different voltage level. So due to this three, so you can also give it a name pseudo ternary code. Ternary means three. So that is why you can say pseudo ternary code. Pseudo, why? Because it the assignment of A and minus A is dependent on the past assignment. So if you assign positive A, then you need to assign negative A. So if you assign negative A, then you need to assign positive A, and so on. So this means that the assignment is alternate, like the positive A and a negative A, the assignment is alternative. For example, so if your data is given 1, 1 and then 1, and you need to give assignment. So if it is positive 1, so you assign positive A. So for next one, you need to assign negative A, and then for next one, you need to assign positive A. So what does that mean? So it means that you need to have one bit for memory, so that the assignment, when you are assigning the next level, you need to know which was the previous assignment, like either it was positive A or negative A. If the previous assignment is positive A, then the next assignment will be negative A, and this is only happening if there are two one, like consecutive one. So if it is 1 0 and then 1, then you don't need to do this type of alternation. But if it is consecutive one, then you can do the alternative assignment. So for that, memory of one bit need to remember the assignment is required in the previous bit, so that the exact assignment is, so that the next assignment is easy. So bit 1 is marked as positive A and negative A. Alternatively, so this method of bipolar is referred to as alternate marked inversion, or AMI code as well. So these are the three techniques: bipolar, polar, and unipolar. So I hope that you understand them very well. So, but if you still have any question, you are most welcome to ask, and we will try our best to answer the question. Thank you for watching the video.